This is a relation in the xy plane. So it has some graph. And there's a point on that, -2, 0. We can check. If you plug in -2 for x and 0 for y, you get equality here. So this point is really on that graph. And at that point, there is a tangent line. We want to find its slope. That's the problem. So we know that the slope is dy over dx. So by implicit differentiation, we can get dy over dx. So here we have a product of two functions. X is one function and the exponential function is another. So we have to use the product rule. Derivative of x is 1 times the second e to the xy plus the first function x times derivative of e to the xy. So this is e to some function. If it was just e to the x, it would just be e to the x. Its derivative would be e to the x. But because of the chain rule, we have to multiply by derivative of the inside function, derivative of xy, which is a product, so we have to use product rule for xy. Derivative of x is 1 times y plus x times derivative of y, which is this, x times dy over dx. So that whole thing is derivative of the left side. Now derivative of the right hand side is 0 because it's constant. Now let's simplify this. This is just e to the xy, and when you multiply this out, you get x times y times e to the xy. That's one of the terms. And x times e to the xy times dy over dx. That's this term here. And now we can plug in -2, 0. One way would be to solve for dy over dx and get a function of x and y, and then plug in the point. Another approach would be to just plug in the point at this point, because all we want is the slope, is this number, dy over dx, after you plug in the -2 for x and the 0 for y. We will get 1 from here, 0 from here because y is 0, and 4 from here because -2 squared is 4, e to the 0 is 1. So you get 4 times dy over dx, and then there is a 1, and then equals 0, and then solve for dy over dx, -1/4, and there it is. The slope is -1/4.